Hello and welcome to our talk, Modular Battery Charging Systems for Industrial Vehicles. I am Mourad Chergui and I manage a broad portfolio of industrial chargers at QuiQ Technologies in Vancouver, Canada. I have more than 15 years experience with commercial and industrial power systems and battery charging solutions. Today, we will look at the requirement for industrial material handling onboard chargers in general. Next, we will dive into modular charging systems, what they are, how they work, and what are the benefits. Then we'll finish with a quick overview of QuiQ technologies and some key takeaways. What are the requirements for an industrial onboard battery charger? The first requirement is simply to survive in a harsh environment. Ruggedness and reliability are mission critical. This means the charger manufacturer should use a rigorous and design validation process. QuiQ Technologies uses techniques from the automotive world, modified for the unique needs of off-road markets. We design for several environmental stress factors, including mechanical, electrical, thermal, humidity, and corrosion. These stress factors are also combined in highly accelerated testing. On the mechanical side, the testing includes extreme one-time and repetitive shock and drop events with forces up to 100 G. This is much higher levels compared to on-road vehicles. Vibration testing on a shaker table simulates a lifetime of harsh use. During the validation and design process, we literally make use of HALT testing, which stands for highly accelerated life testing. This is an extreme test to failure regime that lets us rapidly find weaknesses in a design. HALT testing combines different stress factors, very high level of vibration, and very high level of thermal shock. Sealing is a critical aspect of the charger design, particularly in an outdoor or wet environment. But even in an indoor application, there is often condensation, cleaning fluids, washing, and spray down of the machines. Sealing is needed not just for the charger enclosure, but any cooling fans, displays, buttons, or connectors when they are mated. You are generally looking at an IP rating of at least IP65 or IP66 for spray and pressure wash protection. Lithium-ion batteries are revolutionizing the electric lift market. They offer several benefits. The first one is increased efficiency. Lithium batteries are way more efficient during charge and discharge cycles. Indeed, about 45% of energy is wasted by lead-acid batteries versus only 10 to 15% for lithium batteries. This is not only good for the environment, but less money will be spent on electrical energy to charge the lithium batteries. The second benefit is battery swapping elimination. Less time and labor would be spent by the workers swapping out lead-acid batteries. In addition, lead-acid batteries have significant health and hazards, such as acid spills, toxic and inflammable fumes, and heavy weights. All these hazards are completely eliminated when using lithium batteries. The third benefit is the elimination of the charging room. Due to the space needed for charging and the risks of spills and fumes, most companies that have multiple forklifts powered by lead-acid batteries dedicate a valuable warehouse space that is a separate and well-ventilated charging room. This space may be reclaimed back with lithium-ion batteries powered trucks. Finally, opportunity charging, meaning charging truck batteries when opportunity arises, for example, during breaks or between tasks. This is one of the greatest advantages of lithium batteries. The same practice, opportunity charging, will significantly shorten the life of traditional lead-acid batteries. Opportunity charging enable using the trucks continuously for 3 shifts versus a single shift. and therefore significantly increasing the return on equipment investment. The power required for onboard charger will depend on the size of the battery and how fast it needs to be charged. The battery in turn will be sized to meet the energy and power demands of the vehicle. If a diesel or gas engine is being replaced, a more powerful engine will require a larger battery and a more powerful charger, therefore. The higher the power absorption rate for lithium ion batteries require much larger chargers to take advantage of the many benefits offered by these new chemistries. For material handling equipment in particular, the onboard charger power is usually from 300 watts to 6 kilowatts. Larger vehicles or high-duty cycle applications may demand higher charge power, but that can often be met with off-board DC chargers up to 20 kilowatts of power. The battery voltages are usually from 24 volts to 80 volts. This corresponds to common global limits for safe working voltages. Larger outdoor vehicles with higher traction power levels may require higher voltages like 400 volts or 800 volts, for example. As the charger power increases, where the chargers plug in will change. Residential outlets readily available in every corner of the warehouse can handle power levels up to 1.2 kilowatts in North America and 2 kilowatts in Europe. At the 3 to 6 kilowatt charging level, the charger requires a single phase AC industrial plug. For outdoor applications, an EV charging station may be used. As you move up to the 20 to the 10 to 20 kilowatt, a three-phase connection is needed, and an industrial plug or an EV charging station in Europe may be needed. And then finally, getting to actually the main topic, charger architecture options. Most people, when thinking about onboard charger, are picturing a single large charger at fixed power, like the charger on the right in this slide. But the other possibility is to have a modular charger, a system made of several smaller chargers connected in parallel. These have several unique benefits, which we'll go into in the next few slides. But first, what is a modular charging system? What does it look like and how does it work? Here is a typical configuration. Here is a typical configuration for a modular charging system using Delta Q chargers. The orange dashed box shows chargers that are connected in parallel. On the right side, AC power comes from a single source, which could be an EV charging station or an industrial plug. These are single-phase chargers, but they can also accept three-phase power if they are arranged in a groups of three, with one module on each phase. On the left side, the DC output of all chargers are combined into a single output to charge the battery. CAN bus, shown in this slide in blue, lets the charger communicate with each other, and optionally with the battery management system or the vehicle CAN bus. As shown here, the battery pack is controlling the module charger output current and voltage over CAN bus. The system operates with a primary-secondary architecture, where one charger is designated as a primary, and it controls the operation of the other secondary chargers in order to deliver the desired power. Current, voltage to the battery. Only the primary charger appearing to be a single high power charger is visible to the externally connected CAN bus system. The secondary chargers are transparent. They aren't seen by the outside world. The primary and secondary chargers are identical, hardware and software. So the production line does not need to load special software or make changes, make different chargers. They can pick and place any charger in any position, and the modular charging system will work. So modular charging system like Delta Qs can offer OEMs an interface for communication with standard EV charging station. This supports both North American and European charging stations. It allows the handshake communication with the charging station to enable the power flow while abiding by the AC current limits of the charging stations. We see three key benefits of a modular charging system. The first one is the power is very easily scalable. Up to 6 chargers can be stacked to right-side the output power. This gives the OEMs a lot of flexibility to offer different charger power options. For instance, an OEM might offer a lower power-based charger and the option to add more chargers power for customers who have larger battery packs or need a shorter charge time. This is also an opportunity for the OEM to increase profit with higher margin options. The second benefit is very flexible packaging and mounting. A compact vehicle may not have space for one big charger, but might have a package space that is narrow or awkwardly shaped, or even multiple smaller package space, where multiple smaller modules, can fit into these spaces. And finally, a modular charging system is cost effective. Having a single charger SKU or stocking unit reduces the number of parts that the OEM have to keep in stock or in inventory, both for manufacturing and for field support and service. Before we conclude, let's briefly talk about QuiQ technologies. We are a leading manufacturer of battery chargers for lead acid and lithium ion batteries. We supply chargers to industrial vehicles and machine OEMs. Here are some of the industries that we serve and some of our prominent customers. We are based in Vancouver, Canada, but we have built a dedicated global team with local experts on the ground in Europe, the Americas, and Asia, who are ready to help your team to be successful. We work with you to develop a charging configuration and integration solution. We provide training for staff and service groups, and we assist with field issues or questions about fielded chargers. The key takeaways from these presentations are: first, the industry is changing rapidly, moving for battery-powered electric vehicles. And this means there are an urgent need for onboard chargers that are rugged and fully sealed to stand up the harsh onboard environments. OEMs need to offer a wide range of charging power levels to meet the needs of customers who want more runtime, faster charge times. A modular charging system offers several key benefits: easily scalable power, flexible onboard packaging, and reduced SKU count. Thank you for your attention.